Hi everyone, I hope you are doing good. So I'm your friend Ram. Today we will discuss one DSA problem which is recently asked in one of the interviews, product array puzzle. And the question is, first we will understand the questions and then we will think for the whatever the approach, whatever the algorithms we can apply for this solving this problem, right? And then at the end I will also show you I have added the codes, like I will convert these algorithms, whatever we will think, into the C++ code and I will run it and I will show you that also. So please watch the complete video so that the understanding would become clear about this kind of problems. If you see this kind of related problems, then you can easily solve that. So here the problem is a product array puzzle, and the question is given an array of nums. So one array is given, one array of nums. Nums array is given to us. So this would be our input array basically, and we have to construct one array, right? We have to construct a product array of nums such that nums of I is equals to the product of all the elements of nums except the nums of I, right? So basically it is saying, so we have, this is our input array basically. So let's understand this questions with the example. Says one example is given where one input array is given 10 3 5 6 2, right? So this would be our input array. Basically let's 10, then 3, right? 5, then 6, then 2. So this is our input array, and we have to construct. So this is input array, and we have to construct the output array, right? Basically, the output array, for example, I'll say P is our output array, and this output array should contain product of the all the elements except the ith element, right? So for example, P of I means this is our zeroth index 1, 2, 3, and 4, right? And same here 0, 1, 2, 3, and 4. So now the product means the in P array, in output array, the zeroth value should be the equals to the product of all the elements except zeroth index from the input array. That is, you have to understand, right? And the product of other elements are how many? How much is this? See, for P of I means I equals to 0. Here P of I would be 3 into 5 into 6 into 2, right? We are basically here multiplying all the elements 3, 5, 6, and 2 except ith element, right? And here I is 0, so it would be 180, right? So here the value would be 180, correct? And here for the first I equals to 1, in that case the value of P of I would be multiplications of all the elements except I, this one, this 3, right? This of one index we have 3 values, so we will exclude this 3 and we will multiply all the elements except this 3. So and that would be 600, right? So here 1 would be 600, correct? And here P of I and I equals to 2, in that case the value of the P of I would be multiplications of all the elements except whatever the value at second index, that is 5, so we will exclude this one, right? And it would be 360, right? Here you can see 10, 3, 6, and 2, right? We are excluding this 5 here, correct? So it would be 360, correct? And then when I equals to 3, then it would be 300. I hope you got it now. And for I equals to 4, we are having 900, right? Uh, for I equals to 4, what we are doing? We are doing same thing. We are excluding this 2 and multiply all the elements, correct? So this is our problem. I hope you understood the problem clearly. Now think about the solutions. How can you approach this problem, right? What is the algorithm? What is the approach coming into your mind? Just comment below the video so that we also get to know what you are thinking, right? And so what I'm thinking is, let me explain you. I'm thinking there are multiple approaches of solving these questions. So one approach we can say, so we have multiple approach. One approach we can say the basic approach, brute force, right? And here what can I do? I can take this element, for example, this is our array, right? uh, 10, 3, 5, 6, and 2. So this is our array. So what can I do? For each and every element I will multiply all the elements, right? So for example, if I equals to 0, right, then what I will do, I will go and multiply all the elements except the I, right? So basically, I have to here for multiplication for j is equals to 0 to 4. I have to multiply all the elements except I not equals to j, right? Are you getting? So what I will do here, I will use two loop here. One is for iterating a zero index where filling the value, right? So for example, I equals to 0 means p of I have to fill, and for that what I will do, I will multiply all the elements of from 0 to n element except the I equals to 0 element, correct? And same here I will do, and same for index 1 I will do. 0 to 4 I will iterate and multiply all the elements except I equals to j, right? And so on I will go for n, and here I will n is here 4, right? So let's go by 4 only. So 4, and here I will go from 0 to 4, and here also I will multiply all the elements, right? And here I will exclude 4, right? Because I equals to 4, and if j is equals to 4, in that case I will exclude 4 and I will multiply all the elements. So this is our brute force approach. I hope you understood, because this is simple. You have to take each and every index, and for each and every index you have to multiply all the elements except the that element which is matching with the output array, right? So that is the thing. So here it is taking time like order of n square, n into n, correct? Because for each and every index we are iterating through complete array every time. So this is taking order of n square time complexity. So this is the simple approach, basic approach, and I think you should also start with basic approach, right, in an interview also. And once if interviewer is agree, okay, that is fine. Or if he ask, or you can also suggest him like I can improve this to order of n also. So let me explain that approach also. So I hope you understood it. You can note it down or whatever you want to do, right? And then okay, let me erase this one, and then we will move for the order of n. We will try to optimize this approach to order of n. And meanwhile, you can also think about it. How can we like improvise it, or how can we improve the time complexity of this one? So let's talk about the second approach here. So second approach, what I'm thinking here, what I will do, I will multiply all the non-zero elements. So in this case, we are having all the non-zero, but yeah, in case where we have zero elements, then we will exclude, because if we include the zero also in the multiplications, then that will make all the result to zero. So that's why what I will do, I will store this non-zero elements here. We can say I will say m, I will store in m, and here I will do a non-zero element, right? So all the non-zero elements I will multiply and I will store into m. Also with this, what I will do, I will also count 0 if any, right? So I will say zc, so that will here 0 count. So this 0 count also I will do, right? So these are the two things I will do, and this I can I can do in order of n in one go. What I can do, if it is non-zero, just multiply into the result m, right? Or if it is 0, then just increment the 0 count, right? So for this we can simply add a for loop from I 0 to n, right? And if it is for example nums of I equals to 0, in that case we can say 0 count plus plus, else m equals to nums of I, right? Here m is equals to m into nums of I, we can do. So this way we can do it, right? I hope this is a very simple, right? You can do it, right? So this is the one thing we will do. So here now we have m, right? The multiplications of all the non-zero elements and the 0 count we have. So now we can apply our algorithms. What I'm thinking here, if we have like if the element, right, nums of I, so what we will do, we will go from I 0 to n, right, this here. And if nums of I, right, nums of I not equals to 0, right, nums of I is not 0, means this is the non-zero element, right? And we are having 0 count is 1, right? We are having 0 count, and also with this one what we will do, this zc is not 0, right? Not 0, it means it is having 1 count. Yeah, for one more thing here, if we are having more than 1 0, if because in one go we will calculate the 0 count, and we found that we are having in the input array more than 1 0. In that case what we will do, we will return the empty array. Empty means all the elements with the 0, right? So that we will, why I'm saying that, because for example here let's take one example here. So we have a three element here. This is first element is 10, second element is 0, third element is 0. So output array, what output array will contain here? So in this case all the elements are 0. Why? Because for example 0 index 1 and 2, and here 0, 1 and 2. So for this one, this is non-zero element. So what we will do, we will multiply all the remaining elements 1 and 2. So that is 0, 0, 0. So this would be 0, correct? And for the first index, what we will do, except first index, we will multiply all the elements, and we are having one more 0 in the array, right? So this one 2 at the second index, right? So this will this make all the multiplication to 0, right? 10 multiplied by 0 would be 0, so this would be 0, correct? And same for this one, except this one second index, we will multiply all the remaining indexes, right? All the elements, and here we have 0, so that will make the 0. So that's why I am saying, if we are having, so this will apply for all the cases. If we are having more than 1 0 2 3 or whatever, then the complete array becomes 0, right? The output array becomes 0. So that's why we can straightforward what we can do, if if zero count, if zero count is more than 2 or more than 1 basically, right? More than 1, then just return directly the empty array, so that we can apply, add one condition before going to this logic, right? So that is one. And now if now we are here, so means we are having either the 1 0 count, or the all the elements are non-zero, right? So here, that is why I am saying here, if nums of I is non-zero, not 0, right? And 0 count is not 0, means 0 count is 1, right? So in that case, what we can do, we can directly, or output array, right? P of I directly we can say 0. Why I am saying 0, right? Because the current element, right? So for example, in the same case, right? In the same case here, we have 10, right? So for example, we have here 0, and here we have 5. So output array, how output array should be like this one. So here, this is 0 index 1 or 2. This is 0, 1 and 2. And here, for this one, what I will do, I will multiply this remaining, right? 0 and 5, and that becomes 0. So my condition is here nums of I. I will check nums of I is 10. So that is non-zero, correct? And then Z count, right? The 0 count would also not 0, because 0 count is here 1. We are having 0, right, in the input array. So this is, so that's why what I will do, I will make it directly 0. Why I am saying, because if except this 10 I will multiply, then it becomes 0. So that's why I will put here 0, correct? I hope you understood this condition. The second condition I will check, right? Else, uh, if else if so for example, in this case 1 is true, so nums of I is equals to 0. So here for example, nums of I is 0, right? Nums of I is 0 for the second case here. Nums of I is 0, right? For first index, if we calculate for the first index, then nums of I is 0. In that case, what I will do, I will directly put the multiplication, whatever the non-zero element multiplication, right? Whatever the n value. So in this case, what I will do, P of I is the m, directly we can say, right? And our m is 50. Here what we'll do, m is 50, and z count is 1, correct? So what I can do, I can directly put the 50 here, and then for second same apply, right? And else means we are having the 0 count is 0, right? So in that case, what we will do, in that case, P of I means we are having all the non-zero elements. In that case, we can do P of I equals to m divided by nums of I, right? So for example, here we are having 10 again, right? One more 10, 10, 10, 5. This is our array. So the multiplications of all the elements would be 100, 500, right? 500. Now here in the first index, how like what should be the value here? Nums of I means m divided by nums of I. Nums of I is 10, so 500 divided by 10, that is 50. Right? So this is 0. Basically 0 count is 0, right? So 0 count is 0, so we will go to the else condition here, and m divided by nums of I, that is 50, correct? 500 by 10, that is 50. Here also we will get 50, and here nums of I, that is 500 divided by 5, that is 100, correct? So I hope you understood this approach. This is very simple, right? So what you have to do, you just have to calculate the multiplications of the all the non-zero elements, correct, and the zero count, and this you can do in the order of n, in one go only, in one iterating through 0 to n one time, and then again you iterate and check if nums of I equals to 0, right? In that case you can directly put the multiplication non-zero element. If nums of I is equals to non-zero element and zero count is also 1, right? In that case we can directly put the 0 here, correct, this one 0. And if we are having the nums of I is non-zero element, right, and zero count is also 0, right? All the elements are non-zero. In that case we can divide it by the nums of I respective number. So let me explain, like let me show you the code, because I hope if you understood the algorithm whatever I am thinking. If you are thinking different than this one, then just comment below the video so that we also get to get benefited, right? So let me show you the code here. So let me explain you the code here. You can also write, and if you want this code, just comment below the video. So I'll provide the link, GitHub link there, and then you can access this code as well, right? So here I have a main function here, right? This is our main function, driver function. Here I have added this while loop and all those things to test the multiple use cases. That's why. And here we are giving the array, right? And this is our main logic, where I'm having two variables here. One is for multiplication, storing the multiplication, so that we took m, right? Here I'm taking multi, and here zero count for the counting the zero in the array. And here in one loop I am checking for the multiplication I am calculating, and the zero count I am calculating here, right? And here in the what I am doing here, I am creating one array, output array. This is our output array, and in output array what I am doing, I am initializing all the elements with 0. That is like why I am doing this one, because if I am here checking this, see here I have discussed, right, this one zero count. If zero count is more than 1, in that case I will just simply return this array, right? And as we have already initialized all the elements with 0, so the only the returned array, the output array would have all the elements to 0, and that is your correct output, because we are having the more than 1 0 here in the input array. And if that is not the case, in that case what we are doing, we are applying that whatever the discussed algorithm we have, right? I just implemented it. For loop we have to, and then if nums of I is not 0 and zero count is not 0, right, means zero count is 1, and nums of I is also non zero element, in that case we will simply put the 0. If nums of I is not 0, right, in that case what we will do, we will multiply like we will divide the multiplication divide by the respective number, right, from the input array. And if the nums of I is 0, right, in that case we directly we will not divide it, because if we are dividing the non-zero element divided by the 0, in that case we will get the exception. That's why I have put this condition here, to avoid that runtime exception, right? So I hope, and then here I am returning the multiplication array. So I hope you understood. Let me run it. So let me build it first, and here let's run it. So it is asking for the use case count. So let's take 3, right? So we will get corner cases also. So please enter the array size. So I'm taking array size is 3, right? So 10, and then first take 0 and 0. So I'm taking here the use case where I'm having more than one 0, right? So see here, my output array is 0 0 0, because we are having more than one 0 here. The second use case, it is asking for the array size, let's 3 only, and here I will take only one 0 in the input array, and then see 1, or you can say 5, right? So see here, 0 50 0. Why? Because all the non-zero elements, because we are having one 0 count here, right? So 0 count is 1, right? And all the non-zero elements we will put 0. See here, this is not 0, so that's why we are putting 0. So all the non-zero elements we are putting 0, and for 0 for 0 element we are putting the multiplication. So multiplication is 50. See here, that is why I am getting here 0 50 0, right? The third use case, let's see. So here I'll take the 3 only element. Array size is 3, and the array elements are non-zero. All the I will take this time all the non-zero elements. 10, then 10, and then 5. This is the array we have discussed, right? So let's take this one. Here you see 50 50 100. That is what we have discussed. Because in this case we are having 0 count is 0, right? So we are not going inside this if block. We are going only this one, the second one, where we are having nums of I is not 0, and here we are dividing the multiplication divided by the respective number. So I hope you understood. If you like the approach, if you like the algorithms, if you like anything, then please press the like button. And yeah, suggest me if you have any suggestion. Just comment below the video and let me know, and let me know how you are thinking. So yeah, that's all from my side. I hope you enjoyed the video. See you next time. Till then, keep learning and keep exploring.